Hello 108 students, Mr. McHugh back here with you on section 7.2. I'm going to tackle page 2 here on this video, and we're going to go ahead and start taking on rational expressions that have different denominators, and thus we need to find a least common denominator. Okay, so that's what objective 2 is. And you know, this is similar to what if I had 2/3 plus 1/4. And we were going to figure out how to add those up. The 3 and the 4 in the denominators are not the same. So what we would do here, I'm going to do this just a little different, but I would ask you 3 and 4, what's the smallest number they both go into? Hopefully you will tell me 12. And I would write 12 down here plus 12 over here. Now, what I want you to think about here is something a little different. Excuse me one second here. I want to pull up the different colors. What would I have to multiply the 3 by to get to 12? So 3 times 4. I'm going to stack the 4 over 4. That won't change the value of 2/3. But I'm showing it to you this way because this is what we're going to do with rational expressions down the road. So you need to multiply 2/3 by the equivalent 4 divided by 4, which is 1. Well, watch what happens. 3 times 4 is 12. 2 times 4 is 8. Now, most of you would have done it in this perfectly fine as far as fractions going, but the old way with just fractions would have been 3 goes into 12 4 times. I'm holding my hand up here with the 4 fingers. 4 times 2 is 8. Okay, that's how you're probably used to doing it, but I want you to try this stacking of equivalency. Now, let's try it over here. 4 times what is 12? And you'll say 3 and stack it. So 4 times 3 is 12. 1 times 3 is 3. Now you would have done 4 times 12. Excuse me. 4 goes into 12 3 times. 3 times 1 is 3. But I want you to practice this way. Okay, now from here you've got a common denominator. 12, 8 plus 3. And there's your answer of 11/12. Okay, so with that going on here, finding the least common denominator, these warm-up exercises here, assume these are in the denominator. So mentally think of these as being 1 over 5 times x times y squared, and then think of this as 1 over 2 x to the third y. You're only focusing on the LCD, and they want you to you're only focusing on the denominators, and they want you to tell them what the LCD was, what's common, so both of them will go into it evenly. Okay, so let's go ahead and try a couple of these here. Now the idea here is, I see these are all multiplication. You got factors 5 and 2. What's the LCD is 10. Now look at the x and look at the x to the third. You've got the same base variable. You pick the highest exponent, so you put x to the third. Look at y to the second, y to the first. Pick the highest exponent, y squared, and you're done. If you go back up here, steps for doing these: factor each denominator. Okay, that's a key thing. You're going to see that coming up here in the next problem here. The LCD is the product of all the different factors from each denominator. Remember, DENOM is denominator, with each factor being raised to the greatest power found. That's what I was just showing right here. X to the third, x to the first. You pick the highest one, and that's why you put x to the third there. Okay, so let's go ahead and take a look at a couple more examples here. This one's pretty easy. The only thing you got to remember is k minus 3 is like it's 1 over. That's the whole entire denominator, so that has to be a factor. So I put the parentheses, and k is all by itself, so you list it and multiply them together. Okay, and you want to keep them in factored form if we were going to do this. Okay, now let's get down to C here. Now let's take on a challenge of, you got trinomials in the denominator. These are denominators. Again, I keep writing them like this just to help you with the mental here. Okay, and the key is step number 1 said factor the denominator. So go ahead and use reverse FOIL and write y minus 4 times y plus 2. Reverse FOIL, take this guy, y plus 2 times y plus 1. Okay, now This comma means these are separate denominators. Now, if you were going to come up with the LCD, every factor, every set of parentheses has to be in the LCD. So y minus 4 gets dropped down. Y plus 2 gets dropped down. Okay, now you come over here and you see y plus 2. We've already done it. It's a tiebreaker. You got both of them raised to the first, so you're fine, and you just leave it as y plus 2. Think of it like a tiebreaker. Finally, y plus 1 was not over here, so that all parentheses are factors, so it gets put in the LCD. Okay. You'll see how this comes on the next page here when you actually start adding, subtracting rational expressions with different denominators. Okay, number D, factor. Again, they want you to pretend that's in the denominator, so maybe it helps to go like this just to get it sitting down there. Factor, 8z minus 24, pull out a GCF. There's your 8, remainder of z minus 3 is a factor. Come over here, I see 5z squared minus 15z. I pull out a 5. I pull out a z, a smallest exponent. Okay, and what's left is z minus 3. Okay, now all the factors got to be in there. So you drop the 8, z minus 3 comes down, 5z also comes down, and then you have 8 times 5 gives you the 40, and z, and you've got the parentheses z minus 3. They want you to leave them in this format. You want them to be all factors. If you use the distributive property, you would turn that into an addition of 2 terms. Okay, I think we've covered page 2 here, getting you warmed up with LCDs. We get to page 3, we'll go ahead and start adding, like I mentioned before, rational expressions with different denominators. Okay, Mr. McHugh saying goodbye for now. I'll see you for page 3. Okay, take care.